All right, guys, so for problem number 3, what we have here is we basically have a stoichiometry problem, except that we have a stoichiometry problem that includes heat that is going on. So how do we include the heat that is going on, especially when you're talking about a weird negative number like so? In order to do this, it's actually very, very simple. All you got to make sure that you do is take the heat that is given to you in the problem and treat it exactly as if it was one of your reactants or products and just put it into your equation. So I'm just going to rewrite my equation here. So I've got 2H2S plus 3O2 comes over here to 2H2O and then 2SO2. And then I've got this 1120 kilojoules per mole, right? Please note that it's negative 1120. So that means it's an exothermic reaction. And if it's an exothermic reaction, that means that energy is being given off, or it is being made, or it is being produced. So if it's being produced, that means it's going to end up on the products side, or we are making 1120 kilojoules. Now, as soon as we do that, we can basically treat this 1120 that's here the same way that we treated that 2, or the same way that we treat that 2, or the same way that we treat that 3 or that 2. We can treat that 1120 just like it was one of our numbers. So if that's the case, then check it out. So it wants to know if I have 40 grams of hydrogen sulfide that's burned, then what's going to happen over here with this guy? Well, remember, we know how to do stoichiometry. They're going to start us with some real world unit over here, and then we're going to have to go down to mole world, and then we're going to have to go across to get our other substance. So our first step is to turn this guy into moles. He weighs 34.1 grams per mole, if you look up his masses on the periodic table, which gets you about a 1.7 mole situation going on there. Now, let's just say for the sake of argument that I wanted to go over here to the oxygen. I wanted to compare those two. Remember what we'd do? We'd multiply by the 3 and divide by the 2, right? Just like we did back in Unit 3. Except that I'm not interested in the oxygen, I'm interested in the heat. I'm interested in this guy over here. Well, just use that number instead. So I want to go over here. So I want to go by a 1,120 to 2 ratio because those are the two things that I'm interested in. I mean, these guys are around to balance the equation, but I really don't care about them in this particular problem. So it's an 1,120 to 2 ratio. So 1,120 to 2 at my 117, if I multiply all that out, I get 657 kilojoules, and I'm done.